Hello, Hornets, and welcome. Today, we're going to be taking a look at 4 questions involving optimization. The 4 questions are in front of you, and I would recommend that you take a quick screenshot as we begin going through them. I'm going to read them first, and then I'm going to go and do them. All right, so here we go. So, a farmer wants to construct a rectangular pen using 300 feet of fencing. The pen will be built next to an existing stone wall, so only 3 sides of fencing need to be constructed to enclose the pen. What dimension should the farmer use to construct the pen with the largest possible area? Number 2, a company has started selling a new type of smartphone at the price of $110 minus 0.1x, where x is the number of smartphones manufactured per day. The parts for each smartphone cost $50, and the labor and overhead for running the plant cost $4,000 per day. How many smartphones should the company manufacture and sell per day to maximize profits? Number 3, a rancher wants to construct 2 identical rectangular corrals using 300 feet of fencing. The rancher decides to build them adjacent to each other so that they share the fencing on one side. What dimensions should the rancher use to construct each corral so that together they will enclose the largest possible area? 4, a supermarket employee wants to construct an open top box um, from a 10 by 16 piece of cardboard. To do this, the employee plans to cut out squares of equal size from the 4 corners so the 4 sides can be bent upward. What size should the squares be in order to create a box with the largest possible volume? Alrighty, so these are the 4 problems we're going to be working on, and they are all maximization. Let's go ahead and take a look at number 1. I recommend that you start by drawing a picture. Here is my pen. Here is my wall. The values I'm working with are y, and x, and I know that the area is x times y. So I'm maximizing area, but I have 2 variables. I need to get rid of one of those variables. What do I know? Well, there are 300 feet of fencing, and it must cover the 3 sides with perimeter. So 2y plus x. That means that 300 minus 2y is equal to x, and we'll get rid of one of these variables. I can now say that the area in terms of y is 300 minus 2y times y. Therefore, the area formula is 300y minus 2y squared. Minus 2y squared. I'm now going to be taking my derivative of area, since that's what they want maximized. There we go. And I'm going to set the area equal to 0 so that I can find my maximum. I'm now going to solve for y. Dividing by 4, I get y equals 75 feet. So once I now know that y is 75 feet, I can go back and find x. Since we know x is 300 minus 2y, x has to be 300 minus 150 for x equaling 150 feet. The dimensions are therefore 75 feet by 150 feet, and I would expect you to write a sentence. Let's go to number 2, a company. A company has started selling smartphones, so we're looking at our revenue, and the revenue in terms of x is going to be the cost, 110 minus 0.1x, multiplied by the number of smartphones they sell per day. The overhead, that's their costs, is going to equal $50 per day, so $50 per smartphone per day, and an additional $4,000 for running expenses and labor. We know profit, P of x, has to equal our revenue minus our cost. Well, we know our revenue is 110x minus 0.1x squared, and we know that our cost is that 50x plus 4,000, both of which become negative to get my profit. Simplifying this, I'm going to take away the 50, leaving me with 60x minus 0.1x squared minus 4,000, and this is now what I am going to maximize. Taking my derivative, I end up with 60 minus 0.2x, which means that 0 equals 60 minus 0.2x. I'm now going to solve. 1/5 x equaling 60 means that x is 300 smartphones. The company should manufacture and sell 300 smartphones to maximize their profit per day. That is question number 2. Number 3. We now have a rancher. The rancher wants to make 2 pens adjacent to each other, sharing one side. Notice that means that I have 2 y's, and if I wish, I can either look at it as x and x, or I could just call the entire side x. I'm going to go ahead and use the 4. Now keep in mind, once I find x, in order to get the entire side, I'm going to have to double it. Alrighty, here we go. I know that there are 300 feet of fencing, and that must be used to do 4 x's and 3 y's. I'm going to go ahead and I am going to, let's find what y equals here. So I'm going to go 300 minus 4x divided by 3 is equal to y, and we're trying to maximize the area, and the area is 2 x's times y. So I'm going to go ahead and I'm going to say a of x, the area in terms of x, is going to have to be 2x multiplied by 100 minus 4/3 x. That means that the area formula is going to have to be 200x minus 8/3 x squared. Taking my derivative, a prime in terms of x is 200 minus 16/3 x, leaving me with 16/3 is equal to 200. Don't forget your x, Mr. Lamb. And I'm now going to multiply by 3 and divide by 16 to get x. Now I happen to have my calculator here, so I'm going to go ahead and use that, and I'm going to take 200 times 3 divided by 16, and I get 37.5 feet. Now this is x, so I still have to figure out what y is. My y is up here, and y will have to be 300 minus 4 times that 37 times 5 divided by 3. So let's find that now. 300 minus 4 times 37.5 is 150, divided by 3 gives me 50 feet. So I now know I'm looking at 37.5 by 50 feet for each corral. Once again, that will enclose the largest possible area. Now, keep in mind, if I want to now find what is the total length, keep in mind I just gave you the answer in terms of each corral. I'm going to have to find what 37.5 doubled is, and that's going to give me 75. So I now have 75 by 50 feet should give me the largest dimensions for the entire length. That's 75 feet by 50 feet, or I'm looking at 75 feet divided by 2 times 50 feet if I'm looking at a single corral. Now the final question that we have is the supermarket employee wanting to get the size of the box. So let's go ahead and draw our picture, cutting out a corner. I'm looking at, let's call this y, 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 and y, making this side 16 minus 2y. This length is 10 minus 2y. And I'm trying to get the largest volume. So let's see, our volume is x times y times z. Now I'm going to put in my other dimensions. I'm going to call this z and this x. That means that my z has to be 16 minus 2y, and my x is 10 minus 2y. These are now my linking equations going into the volume formula, and I'm now going to have 10 minus 2y times y times 16 minus 2y. This is going to give me a volume formula that is 160y minus 52y squared plus 42y cubed, having already multiplied it. I'm now going to take my derivative, v prime. This is giving me 160 minus 104y plus 12y squared, setting it equal to 0 and solving. I end up getting y minus 2, and I end up having, or I have, what's that going to be, 1820 and 3y. This gives me two possibilities, 2 or 20 thirds, but 20 thirds is too large and therefore is not within our appropriate domain. So I'm now going to go to my only option, 2, and that means that the squares are 2 inches by 2 inches. So the employee must cut out squares of 2 by 2 inches in order to maximize the volume for the box that he is trying to make, given the dimensions of 10 by 16 piece of cardboard. Thank you very much. I hope this has helped. Please feel free to offer any advice or comments. And if you like it, please give me a like. Thank you very much, Hornets. Have a great day. Take care, and please be safe. Bye-bye now.